The ideas that form the basis of science are actually fairly simple to understand. Science uses organized skepticism to find natural explanations for physical events. This is using experimentation and observation to create theories based off of the world. An important thing to note, however, is that our theories about the world have to be self-consistent with one another. This is simple enough to understand when we think about the concepts in biology, chemistry, and quantum physics. We have certain biological theories. We know about cells and about certain processes within our genomes. The reason these biological theories are consistent with our chemical theories is that we know that at the basis of biology is chemistry. And chemistry, furthermore, is self-consistent with our understanding of quantum mechanics in that our quantum mechanical theories can actually be used to explain why certain chemical events happen and how chemical reactions occur. So as is evident in this explanation, all of our scientific theories, at some level, are consistent with one another, whether it be cosmology, geology, biology. But there's a problem in modern physics today. That problem resides within the two most accurate theories we have ever produced. Those theories being quantum mechanics and Einstein's general relativity. These two theories are inconsistent with one another because relativity works on the largest scales of our universe, helping us understand stars and black holes and the movement of galaxies, planets, and stars, where quantum mechanics is the most accurate theory of small particles on the smallest scales of our universe. For example, quantum mechanics is used to understand the behavior of electrons and all of the other particles in the Standard Model. The problem is that at the smallest scales, where quantum mechanics is at work, relativity actually breaks down, and vice versa. Therefore, these two theories that explain the entirety of our universe as we know it aren't consistent with one another. This inconsistency, along with our desire for a natural explanation of all of the events within our universe, forms the basic source of why we as physicists are searching for a theory of everything. There have been many different ideas and theories throughout the years on what this theory of everything might actually be. But as I will explain to you, one of these theories might actually be a theory of higher dimensions. So what do I mean by this? As you live and breathe and experience the world around you, you're only really aware of 3 spatial dimensions. You can go forward or backward, left and right, and up and down. Within these 3 spatial dimensions, we live our lives. So that's all we're really familiar with. But really, philosophically and mathematically, there's nothing special about 3 dimensions. For example, mathematically, we can understand what a 4-dimensional or a 5-dimensional or a 6-dimensional world might look like. Of course, we can't visualize this in our minds, specifically because we've evolved in these 3 spatial dimensions of our universe. Actually, for most of history, a 3-dimensional study of geometry, or Euclidean geometry, was all we really had. Yet in the middle of the 19th century, a brilliant mathematician named George Bernard Riemann was the first to create a mathematical theory of higher dimensions. It's fairly simple to understand how a higher dimensional world could be understood mathematically. Here's a quick explanation of that. Although I won't get into the mathematical complexity of George Bernard Riemann's mathematical theory of higher dimensions. First, picture a straight line. This is one dimension, forward and backwards. Now picture a square. Squares or rectangles, as you know, have length and width, 2 dimensions. And now finally a cube, a 3-dimensional object with length, width, and height. We can actually find the area of this cube by multiplying the 3 side lengths together. Imagine this cube's side lengths are 3 centimeters each. 3 times 3 times 3 is 27. Therefore, this cube's volume is 27 cubic centimeters. But we can take this to the next level, adding a 4th dimension. Of course, you can't picture this in your mind, and we can't really have a picture of it on paper. But imagine an unseen 4th spatial dimension. As you know, every infinitesimally small slice of the cube we had earlier would be a 2-dimensional square. In this case, with the 4th dimension, any infinitesimally small slice of this 4th dimension would be what we have here, a cube. And we can even measure the 4-dimensional volume of this hypercube, if you will, by multiplying the 4 side lengths together, as we would do with a square and a cube, and now a hypercube. 3 times 3 times 3 times 3 is 81 centimeters to the fourth power. Now, this four-dimensional volume doesn't really mean anything in our 3 dimensions, but of course mathematically it would mean something in 4 dimensions. So, as hopefully I've convinced you, we can understand 4 dimensions or 5 dimensions or any number of dimensions mathematically. George Bernard Riemann's mathematical ideas about higher dimensions and his metric tensor were actually used by Einstein to understand his theory of general relativity. Einstein, instead of adding a 4th spatial dimension, actually viewed the 4th dimension as time. It's easy to think about time as the 4th dimension because you can imagine that our 3 dimensions and the world in which we're living is moving through this 4th dimension of time. And with time as the 4th dimension, Einstein understood that time and space aren't actually separate, but rather a single entity, space-time. This theory certainly gives us a lot of extraordinary physical understanding. For example, the existence of black holes, and the fact that the closer you move to the speed of light, or the closer you are to something extraordinarily massive, the slower time moves for you relative to the rest of the universe. And Einstein, after creating this theory, one of the greatest theories we have on the grand scale and changing our physical understanding of the universe, spent a lot of the rest of his life searching for a grand unified theory in which he could explain the entire universe. He actually criticized quantum theory, saying the words, "God does not play dice." Now this is where string theory comes in. As we have seen, adding a 4th dimension simplifies the laws of nature, combining space and time. Now extending that line of reasoning, modern-day theoretical physicists, or string theorists, have in part created a theory of 10 dimensions. In this 10-dimensional theory, all the particles and forces of nature are basically 10-dimensional strings oscillating at different rates, creating the different particles and forces in our universe. As the 10-dimensional string theory is, it actually contains within itself both relativity and quantum mechanics. And if this theory is true, it actually could explain the entirety of our universe in one general theory, a theory of everything. Now you may be asking, how can this be proven, or has it been proven in any meaningful way? The answer is simply no. It hasn't been proven. Mathematically and theoretically, the theory makes sense with what we see in the universe, but experimentally, we would need extraordinary amounts of energy to actually probe our universe to test whether or not this theory is true. It might be centuries before we can actually test string theory to know whether or not it's actually true. Nonetheless, string theorists continue to refine this theory of higher dimensions, and hopefully will find some indirect way of confirming the theory, and not have to wait centuries, or never confirm it at all. So we have to be honest about this. We do not know whether or not string theory is actually true. I personally hope that it is, and that we'll be able to confirm it sooner than later. But in reality, we have to accept that this theory has not yet been proven, and we have to keep pushing science forward and pushing back the boundaries on what we know. This has been a brief introduction to higher dimensions and string theory. I hope you enjoyed it. Hello, this is Kendall Butler. I hope you enjoyed that video. The greatest resource I had in completing this video was a book written in the late 90s by Michio Kaku, Hyperspace, a scientific odyssey through parallel universes, time warps, and the 10th dimension. Links to other resources I used in creating this video are in the description. Please like, comment, and subscribe, and have a nice day.